Hello everyone, in this video we are going to solve questions from Cambridge International AS and A-Level Mathematics, Paper 5, Probability and Statistics 1. So these questions were taken from February-March 2024 examination. Okay, let's take a look at question number 1. Okay, for question number 1, we have a bag contains 9 blue marbles and 3 red marbles. One marble is chosen at random from the bag. If this marble is blue, it is replaced back into the bag. If this marble is red, it is not returned to the bag. A second marble is now chosen at random from the bag. For part A, the question is find the probability that both the marbles chosen are red. Okay, so we want both the marbles chosen are red. So in this question, I recommend you to draw the tree diagram to illustrate the situation. So we take two marbles here. This is the first marble. This is the second marble. And for the first marble, there are two possibilities. Either we get a blue marble or a red marble. So that's why I write here blue and red. The total marbles that we have is 12. And we have 9 blue and 3 red. So that means the probability of getting a blue marble is 9 over 12 here. And the probability of getting a red marble is 3 over 12. Now, a second marble is chosen. So for the second marble, there are also two possibilities, blue and red. If the first marble is blue, it is replaced back into the bag. So that means the total number of marbles is still the same, which is 12. So here, the probability of getting a blue marble for the second time is still the same, which is 9 over 12. And for the red marble is also the same, 3 over 12. However, if the first marble is red, it is not returned to the bag. So this means that the total number of marbles is reduced by 1. So it now becomes 11. So we can see that for the blue marble, it is 9 over 11. And for the red marble, for the second time, it is 2 over 11. Why is it 2? Because we have taken one red marble before and it is not returned. So the remaining red marbles is 2. And then over 11. So the probability that both marbles are red, you can see that this is red, so 3 over 12 multiplied by 2 over 12. And you will get 6 over 132. And if you reduce this fraction, you will get 1 over 22. That's for the first question. For question part B, we would like to find the probability that the first marble chosen is blue, given that the second marble chosen is red. So you have to pay attention to this keyword, given that. So this means this question is actually about conditional probability. And remember again that the formula for conditional probability, we have probability of A given B is probability of A and B divided by probability of B. So you can consider that the first event is for blue marble, and I denote it by B1 here. And then the second marble is red marble. The second event, is red marble, and I denote it as R2. And based on the formula of conditional probability, probability of getting blue marble for the first marble, given that the second marble is red, is given by probability of B1 and R2 divided by probability of R2. Now for probability B1 and R2, that means it is just probability of B1 multiply, remember N means multiply, by probability of R2. So the second marble is red. How about the bottom one here, probability of R2? So probability of R2 in this case means that the second marble chosen is red. And you can see from our tree diagram, if you want to get red marble for the second marble, you can have this one and also this one. So you can have the first marble is blue and the second is red, or the first is red, the second is also red. That's why I write like this, B1 and R2, or R1 and R2. And you can just plug in the probability values. Here 9 over 12 multiplied by 3 over 12. and for B1 is 9 over 12 times 3 over 12, or means you have to add by this one. R1 is 3 over 12 and R2 is 2 over 12. Work this out real quick. You will get the probability is 33 over 41, and that's it. That's for the question number 1. Okay, for question number 2 here, Sam is a member of a soccer club. She is practicing scoring goals. The probability that Sam will score a goal on any attempt is 0.7, independently of all other attempts. Part A. Sam makes 10 attempts at scoring goals. Find the probability that Sam will score goals on fewer than 8 of these attempts. So if you notice, it is actually a question about binomial distributions. First of all, you can define the random variable x here to be the number of goals on 10 attempts, because we have 10 attempts here, and since it is a binomial distribution, so you have to mention the parameters. There are 2 parameters of binomial distributions, which are n, l, also p. N is the number of trials, which is 10 here, and p is actually the probability of success, which is 0.7 in this case from the question. We would like to find the probability that Sam will score goals on fewer than. So the word fewer than means less than. There is no equal sign, only less than 8. So if you want to calculate probability of x is less than 8, it is quite difficult if you use this directly. It means you have to add probability x equals 0 plus probability x equals 1 until probability x equals 7. So we have a lot of things that we need to calculate. So for simplicity purposes here, let me use the complement, which is 1 minus probability x is greater than or equal to 8. Remember, you have to include the equal sign, because in a discrete random variable, the equal sign matters. Yeah, you cannot ignore it. So probability x is greater than or equal to 8 means that probability x is equal to 8, 9, and also 10. And then you can now use the binomial distribution formula. Yeah, binomial distribution formula. If you don't remember, you can see on list MF19 here. So you can use this one. This is the formula for binomial distribution. So you can just plug in when x equals 8. So it means like this, 10 combination 8. And then this is p, 0.7 to the power of 8. And then this one is the probability of failure, which is 1 minus probability of success, which is 0.3. And you do the same thing with probability x equals 9 and probability x equals 10 like this. Work this out using your calculator and you will get the result is 0.617. Okay, for the second question, or for part B, find the probability that Sam's first successful attempt will be before her 5th attempt. So here, we define another random variable. Let's say x is the number of attempts until Sam's first successful attempt, like this. And if you see, the keyword now is first successful attempt. So remember that in probability and statistics 1, you only learn 2 discrete distributions. The first one is binomial, and the second one is geometric. And for the geometric distribution, it is about the number of trials until the first success. So that's about geometric distributions. So for part B is actually a geometric distributions. And for geometric distributions, the parameter is only 1, which is p, the probability of success. And it is still the same, which is 0.7. So we would like to find the probability that Sam's first successful attempt will be before her 5th attempt. So that means we would like to find probability x is less than 5. Okay, we would like to find this one. You can do it manually, like probability x equals 1 plus probability x equals 2 until probability x equals 4. that's totally okay, and you can use this formula. And if you don't want to use this, you can actually use the following formula. Yeah, for geometric distributions only, probability x is less than or equal to r is given by this one. Remember that we have to have less than or equal to, but originally we only have less than. But it's okay, we just need to modify a bit. We know that x is less than 5 is actually the same as x is less than or equal to 4. So now the notation matches with the general formula. So r is 4, so that means this is like this, yeah. It should be 0.7 here, and then this one is 0.3. So 1 minus 0.7 to the 4th power, and this is 1 minus 0.3 to the 4th power. Again, using your calculator, work this out, and you will get the result is 0.992. Okay, for part C, Wei is a member of the same soccer club. He is also practicing scoring goals. The probability that Wei will score a goal on any attempt is 0.6, independently of all other attempts. Wei is going to keep making attempts until he scores 3 goals. The question is, find the probability that he scores his 3rd goal on his 7th attempt. So that means after the 7th attempt, he will stop because he has made 3 goals. Okay, so we can illustrate this question like this. We have 7 attempts, yeah, and we know that the last one here should be a success. S stands for success here, which means he scores his 3rd goal. So that means for the first 6 attempts, we need 2 successes, right? Because our goal is to make 3 goals. So you can say that x is actually x is a random variable that denotes the number of successes from 6 attempts. Yeah, and we know x has a binomial distribution where n is equal to 6 and p is 0.6. Okay, we need 2 successes, so that means the probability is given by the following formula. And then you can work this out for the total probability. For the first 2 successes is given by the whole formula here. And for the last one, the 3rd success is given by 0.6, the probability. And then work this out, you will get 0.0829. Okay, for the next question, number 3. The time taken in minutes by 150 students to complete a puzzle are summarized in the following table. So we have the time taken given in intervals and also the frequency for each time taken. Okay, for the question part A, we have to draw a histogram to represent this information. Alright, so if you have a question about drawing a histogram, the first thing that you have to check is whether the length of the intervals is the same. If you take a look here, the first one, the length is 20. Yeah, 20 minus 0 is 20. For the second class or the second interval, the length is 30 minus 20, which is 10. And we know that 20 and 10, they are not the same. So if you see this kind of situation, you have to find the frequency density before you draw the histogram. So we don't use frequency on y-axis. Instead, we will use frequency density on the y-axis. Okay, how to calculate frequency density? So frequency density can be calculated by, you have to know the frequency of the class and then divided by the class length or the interval length, like this. Yeah, so here you have to find the length of each class, which is given by this one, and then find the frequency density. So for example, the first class here, it has a frequency density of 8 over 20, which is 0.4. For the second class, 23 over 10, which is 2.3. For the third class, 35 over 5, which is 7, and so on and so on. After you get the frequency density, you can now draw a histogram. On the x-axis, it will be time taken in minutes, like this. And for the y-axis, it should be frequency density. Remember, not a frequency, yeah. So you can just draw a histogram. For example, the first one here, the frequency density is 0.4 and the interval is from 0 to 20. So you can make like this, from 0 to 20. And in this case, for the y-axis, each grid represents 0.2. Like this, yeah. So you have the following. And you can do the same thing for the rest of questions, yeah. The rest of intervals. Like that. And for this 50 to 70, oh, it should be, I'm sorry, here it should be until this one, yeah. So just ignore this part. Yeah, you should draw until this one. Okay, so that's about question number A. For part B, calculate an estimate for the mean time for these students to complete the puzzle. Because our data is continuous, we cannot find the actual value of the mean. So we only can find the estimate for the mean. How to find the estimate for the mean? You have to find out the midpoint multiplied by frequency. Well, technically, sum of midpoint multiplied by frequency divided by sum of frequency. Okay, now you have to find midpoint first, midpoint for each class. For the first class here, 0 until 20, the midpoint is 10. How to find this 10? You can do like this, 0 plus 20 divided by 2, and you will get 10. And for the next class, that means 20 plus 30 divided by 2, which is 25, and so on and so on. After you get the midpoint, you have to multiply the value by frequency. For example, for the first class, it is 8 multiplied by 10, which is 80. And then for the second class, 23 multiplied by 25, which is 575, and so on and so on. And then you sum all the values here, likewise the frequency. So the estimate for the mean would be this value divided by sum of frequency. And you will get it is 35.75 for the estimate for the mean. That's for question part B. For question part C, in which class interval does the lower quartile of the times lie? So you have to know that we have 3 quartiles here. The first quartile, yeah, or it is also called as lower quartile, which is Q1. The second quartile, which is the middle quartile, and it is also the same as median. And then we have the third quartile or the upper quartile, it is Q3. Okay, now how do we find the class interval that contains the lower quartile? You have to know that quartile divides data into 4 equal parts. So you have to find out the position of Q1 first. And to get the position of Q1, you have to do the following. 1 over 4 of n. What is n? N here is the total frequency, which is 150. So it means the position of Q1 is located at the 37.5th value. And now you have to determine that which class interval contains the 37.5th value. So you can take a look here. For example, the first 8 values are contained in this class interval. And then the next 23 values, so the total here is 31. They are contained in this class interval. If you add again, 31 plus 35, that means it is 66, yeah, until 66 value, they are contained in this class interval. So that means 37.5 value is contained in this class interval. So that means the lower quartile or Q1 lies in this class interval. That's how you answer this question. Okay, now question number 4. A company sells small and large bags of rice. The masses of the small bags of rice are normally distributed with mean 1.20 kg and standard deviation 0.16 kg. Part A. In a random sample of 500 of these small bags of rice, how many would you expect to have a mass greater than 1.26 kilogram? Okay, how many would you expect? First of all, you have to find the probability that a mass is greater than 1.26 kilogram. We can define the random variable x to be the masses of the small bags of rice, because we are interested in small bags here. And then from the question, we know that x has a normal distribution with mean 1.20 and variance 0.16 square. Remember, variance is standard deviation square. Okay, now we would like to find out the probability that the mass is greater than. So that means the sign is greater than, like this. Probability x is greater than 1.26. Remember that if we are dealing with normal distribution, we have to bring it to a standard normal distribution in order to use the table. And you have to know the transformation that we use is given by z is equal to x minus mu over sigma. Remember, this is the mu and sigma square. Yeah, so mu is 1.20 and sigma only is 0.16. So that means x now becomes z, and the sign here stays the same, greater than, and then now x minus mu. So 1.26 minus mu is 1.20 divided by sigma, which is 0.16 here. Work this out, we get probability z is greater than 0.375. Remember that in the table, we don't have the value for probability greater than some number. So we only have probability less than a number. Yeah, so we have to rewrite this as 1 minus probability z is less than or equal to 0.375. And you have to figure out the value for this probability from the normal table. So we would like 0.375. Now we see that 0.3 is here, 7 is here, and then 5 is here, yeah. So it means you have to add 0.6443 by this one. Yeah, and for this one you have to write like this, 0.0019. Yeah, you add this one, you will get this as 9 plus 3 is 2, yeah, 2, 1, and then 6, 4, 0, 6, yeah, like this, yeah, 0.6462. So that means this is 0.6462. 1 minus this is 0.3538. That's the probability. Okay, remember that our question is not asking for the probability, but the number, yeah, the expected number of bags that have a mass greater than 1.26. So after you find the probability, you have to multiply by the number of samples, in this case, the number of small bags, 500. So you have to multiply by 500. You will get 176.9. And since our context is about the number of bags, it doesn't make sense if we have 176.9 bags. So you have to round it up. Becomes 177 bags. Yeah, so this is the expected number. Okay, the next one. The masses of the large bags of rice are normally distributed with mean 2.50 kilogram and standard deviation sigma kilogram. 20% of these large bags of rice have a mass less than 2.40 kilogram. Okay, for part B, find the value of sigma. We can define x to be the masses of the large bag of rice, and now x has a normal distribution with mean 2.50 and variance sigma square. We don't know yet what sigma is, and that's our question actually. We would like to find the value of sigma. Okay, you can start by rewriting this statement in a mathematical equation. 20% of these large bags of rice have a mass less than 2.40. So that means probability x is less than 2.40 is 20%, which is 0.2. And again, we have to bring this probability distribution into a standard normal distribution. So you have to do like this, 2.40 minus mu, yeah, this one is the mu, which is 2.50 divided by sigma. And we get probability z is less than negative 0.1 over sigma. Okay, we have to figure out this value from the table. Yeah, probability z is less than what number will give you 0.2. If you try to illustrate it like this, so that means this is 0.2, yeah, the area is 0.2, and actually we would like to find out what is the z value for this one. And we know that we don't have the value for negative number on table. Why do we know this is negative? Because this one negative 0.1 over sigma. Sigma is always positive, yeah, so negative divided by positive. So that means the number inside here should be negative. We don't have the value for negative z value on the table, so you have to modify a bit. Since we know that a normal distribution is actually a symmetrical distribution, that means if the area here is 0.2, the area here is also 0.2. And we can find out the z value here, yeah, at this point from the table. Yeah, and it means if the whole area here is 0.2, the rest is 0.8. So you don't use 0.2 again now. You use 0.8, yeah, the whole area. The area less than or equal to this number. Yeah. And if you take a look here, 0.8, it is actually from the following. Yeah, this is the closest one, 0.7995, but you have to add by 5 here. Yeah, so that means 0.842, 0.842, and you get like this. And don't forget to include the negative sign, because this is the negative value. Yeah, negative. This one is positive, 0.842, and this one is the same actually, but it is a negative version. So negative 0.842. And we get negative 0.1 over sigma is the following. So that means sigma is 0.119. Okay, the next one, a random sample of 80 large bags of rice is chosen. Use a suitable approximation to find the probability that fewer than 22 of these large bags of rice have a mass less than 2.40 kg. So I think for this question, the keyword is already clear. Yeah, use a suitable approximation. So you have to use approximation. Okay, first of all, define again x to be the number of large bags of rice having a mass less than 2.40 kg. Originally, x is a discrete random variable that has a binomial distribution where n is 80 and p is 0.2. How do we know p is 0.2? Because here is the probability that the large bags of rice have a mass less than 2.40. It is actually given from part B here. Yeah, 20% of these large bags of rice have a mass less than 2.40. So we use this value again in answering part C. Yeah, so originally we have the following, and we would like to find out probability x is less than 22, but since it's quite difficult for us, since we have to calculate a lot of things, we can bring this binomial distribution to normal distribution. Yeah, we approximate the binomial distribution using the normal distribution. Okay, now for normal distribution, the parameters are mu and also sigma square, the mean and also the variance. How do we find them? For the mean here, yeah, you use the mean value for binomial. Yeah, so mu is actually n multiplied by p, which is 80 multiplied by 0.2, and we get 16. So here the mu is 16. For the sigma square, for binomial, it is np multiplied by 1 minus p. So this is actually 80 multiplied by 0.2 multiplied by 0.8, and you will get 12.8. So this is the value for sigma square. Yeah, remember originally we have a discrete distribution. Now we have a continuous distribution. Yeah. So from discrete to continuous, you have to do the continuity correction. And don't forget to do the continuity correction. How to do that? Yeah, originally we would like to find probability x is less than 22. So x is less than 22. This is 22, so that means 21, 20, and so on and so on. So the value starts from 21, 20, 19, and so on and so on. So from the continuity correction, you have to start from this one, 21.5 to the left. So that means this one, 22, should be subtracted by 0.5, and you will get 21.5. And then minus mu, which is 16, over sigma. Remember, 12.8 is sigma square, not sigma. So you have to take the square root of 12.8 in order to find the sigma. And you will get this one, 1.537. Using the table again, the probability z is less than 1.537 is actually 0.9378, like that. So that's the answer for question number 4. Okay, now we continue to number 5. For number 5, Anil is taking part in a tournament. In each game in this tournament, players are awarded 2 points for a win, 1 point for a draw, and 0 points for a loss. For each of Anil's games, the probabilities that he will win, draw, or lose are 0.5, 0.3, and 0.2 respectively. The results of the games are all independent of each other. The random variable x is the total number of points, is the total number of points that Anil scores in his first 3 games in the tournament. Part A. Show that the probability x is equal to 2 is equal to 0.114. Alright, so now the random variable x is the total number of points. And we can see that from the question, we can have 2 points if we win, 1 point for a draw, and 0 points for a loss. Right? So here, in order to get the x is equal to 2, or in other words, total number of points is equal to 2, you have to list down all possibilities. Okay, here are some possibilities. Win, lose, lose. So that means if the first one is win, we get 2 points. And then the second and the third one we lose, we don't get any points, just 0 points. So 2 plus 0 plus 0, that means we have the total number of points is equal to 2. And this one can also lose, win, lose, or lose, lose, win. So we have 3 possibilities for the first one. Another possibility that we can have is the following. The first one is draw, the second one is draw, the third one is lose. Because when we draw, we only get 1 point. So this is 1, this is 1, this is 0. 1 plus 1 plus 0, that means the total number of points is 2. And similar with the previous case, we can also have draw, lose, draw, lose, draw, draw. So that means probability x is equal to 2 can be found using the following. 3 times probability win, lose, lose, plus 3 times probability draw, draw, lose. Why do we need to multiply by 3? Because for each possibility here, for each possibility for this one, and this one, they have the same probability. So we don't need to list all of them, just multiply by 3 and the result is still the same. And similar with this one, So we can put all the probabilities value according to the question here. Win is 0.5, draw is 0.3, and lose is 0.2. So we can write the following. Work this out and you will see that it is actually 0.114. So we have shown that probability x is equal to 2 is 0.114. 4. Okay, part B. Complete the probability distribution table for x. We have 3 missing values here for x equals 0, x equals 1, and x equals 5. Alright, now for probability x equal to 0, we have to think how can we get the total number of points is equal to 0. That means all of the games he should be lose, right? Because the points is 0. So that means for the first one, lose, 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 and the probability is the following. And for probability x equals 1, we can have the following: draw, lose, lose. Yeah, draw is 1, lose and lose is 0. And again, we have to multiply by 3 because of the similar reason. We get the following, and probability x equals 5, we can do win, win, draw, and we get the following. So this is 0.008, 0.036, and 0.225. Or if we want to find out probability x is equal to 5 without using this one, we can also have another approach, which is you can just 1 minus the sum of all probabilities that we have found. Remember, the sum of the probabilities is equal to 1. So in order to get this, you can do 1 minus the sum of the whole values here. And you get the same result, which is 0.225. So either way is okay. Alright, for part C, we have to find out the variance of x. Yeah, remember variance of x is given by this one. Variance of x is actually expected of x squared minus expected of x and then square. So you have to find two things, expected of x squared and also expected of x. First of all, we can find expected of x, and to find expected of x itself, it is just sigma of x multiplied by probability x equal x like this. Yeah, the value multiplied by its probability, and you sum all of them. Yeah, you can refer back to the probability distribution table here. 0 multiplied by this is 0, plus 1 multiplied by this, plus 2 multiplied by this, and so on until the last one. And you will get 3.9. For the expected value of x squared, it is actually pretty much the same as finding expected of x, but now you have to square the x first. Yeah, so we have 1 square, 2 square, 3 square, 4 square, and so on and so on. Work this out, you will get 17.04. So, variance of x should be equal to expected of x squared. So, variance of x is expected of x squared minus expected of x and then square. And then just substitute the values, you will get the variance of x is 1.83. And that's for the answer for question number 5. Okay, the last question here, number 6. A new village social club has 10 members, of whom 6 are men and 4 are women. The club committee will consist of 5 members. Part A. In how many ways can the committee of 5 members be chosen if it must include at least 2 men and at least 1 woman? Okay, first of all, again, you have to list down all possibilities. Yeah, for this one, we need to pay attention here. At least 2 men and at least 1 woman. So we can list the possibilities first. At least 2 men, it means if we have 2 men, we must have 3 women. Or if we have 3 men, we must have 2 women. If we have 4 men, that means we must have 1 woman. And that's all the possibilities. We cannot have all of them are men because we must have at least 1 woman. Okay, for the first one, 2 men and 3 women. We have 6 men and 4 women. So to choose 2 men for 6 men, it means 6 combination 2. Multiply by We have 4 women and we would like to choose 3 of them, so that means for combination 3. Work this out, you will get 60. For the second one, 3 men, 2 women, so that means 6 combination 3 for the number of men, and then for combination 2 for the number of women. Work this out, you will get 120. And for the last one, we will get the same, which is 60. So the total ways is equal to 60 plus 120 plus 60, which is 240. That's for question A. For question part B, the 10 members of the club stand in a line for a photograph. How many different arrangements are there of the 10 members if all the men stand together and all the women stand together? All the men stand together and all the women stand together. So we have like this, yeah, we have 10 places because we have 10 members. And then we have 6 men, 4 women. That means we can assume that the first 6 places are for men and they must be together. Similarly, the last 4 places are for women and they must be together as well. So we have 6 men and 4 women. So that means 6 factorial for the number of arrangement for men, multiply by 4 factorial. This one is for the number of arrangements for women. But don't forget that men and women, they can be interchanged. So we can have women first and then followed by men, or men first then followed by women. So we have to make we have to multiply by 2 factorial. Yeah, one is for arranging 2 objects. We can consider that men and women, they are 2 different objects. And then 6 factorial is 720, multiply by 4 factorial is 24, and then 2 factorial is 2, and you will get this one. Okay, the last question here. For a second photograph, the members stand in 2 rows, with 6 on the back row and 4 on the front row. Oli and his sister Petra are 2 of the members of the club. Part C. How many different arrangements are there of the 10 members in which Oli and Petra stand next to each other on the front row? Okay, so this is the condition. Oli and Petra stand to each other on the front row. Okay, we have 6 places for the back row. We can make like this, and we have 4 places on the front row. And for the front row, we have Oli and Petra. So we can make like this. Okay, we can make like this, Oli and Petra, or we can also have Oli and Petra here, and we can also have Oli and Petra here. So if you pay attention for the front row, there are actually 3 possibilities for Oli and Petra, like this. Okay, and then we have placed Oli and Petra. So that means we have the remaining 8 possible places, and these 8 possible places are for the other members. Yeah, so how do we do this question? Okay, we have 3 here because again we have 3 possibilities only for Oli and Petra. Multiply by 2 factorial. What does it mean? Remember, similar as question part B, we can interchange the position of Oli and Petra. So we can have Oli and Petra or Petra and Oli. So you have to multiply by 2 factorial. And lastly, we have to multiply by 8 factorials because we have 8 empty places, yeah, for the remaining 8 members. Yeah, we have to multiply by 8 factorial, and this is the result. Okay, so that's it. We have solved our questions from this paper. I hope that this video is beneficial for you, and thank you for your kind attention.